In this lesson, we're going to learn a method to factor trinomials called the box method. So we can use the box method to multiply binomials like this. I'll link that video up here, but we can just do a quick review. When we set up the box method, I just take one of my binomials here, and I'm going to put it on top, and the other one I'm going to put down the side. And now we're just going to multiply whatever two terms meet up in that box. So I'm going to have x squared, because here I have x times x. Then I have 4 times x, which will just give me plus 4x. X times 3 will just give me plus 3x. And then I've got 4 times 3, which will just give me plus 12. Now once we multiply, we can combine our like terms, which is usually on the diagonal, which is just 4x and 3x. So I get x squared plus 7x plus 12. So that's just a review of how we can use the box method to multiply. We know that factoring is going in reverse. So we're going to be starting here and ending up here. So let's see how we can use this box method to go in reverse now. So for my box method, when I set it up, I'm going to have my ax squared in this first part. So we've got these quadratics in standard form, ax squared plus bx plus c. And so my ax squared is going to come into this first box. And then my c term is going to end up in this last box. And now in these two diagonal boxes, we're looking for what we call two key numbers. Okay? And so these key numbers are important. My key number 1 times my key number 2 need to multiply to my a term times my c term. And those same two key numbers need to multiply to my b term. And I'm getting these from my original equation here. So we're going to multiply a and c to get these key numbers, and those same key numbers need to add or subtract to b. Once we have this box set up, we're going to find the GCF horizontally here. So I'm going to write the GCF of this, so I can write it like that, and the GCF here as well. And then on the top is going to be our GCF remainders, okay? GCF remainders. And so these are going to be our two factors, just like they were on the last example. So for our review, we multiplied x plus 4 times x plus 3 to get this. So now let's try and use the box method to go in reverse now. So I'm going to set up my box. And so my a in this case, my a is always the number attached to the x squared. But since I don't have a number listed here, I'm just going to call a 1. My b is attached to my x, which in this case is 7. And my c is the number that's left, which is 12. So I'm going to write x squared in this first term, or sorry, in this first box. And then c, which is 12, is going to go in this last box. And so now we're going to find our two key numbers. So a times c is just 1 times 12, which just gets us 12. And so now let's think of some numbers that would multiply to this and add to 7. Well, 6 times 2, that multiplies to 12, but it doesn't add or subtract to 7. Something in what else multiplies to 12? Well, we can separate this into 3 times 4. 3 times 4 is going to multiply to 12. And 3 plus 4 adds to 7, which is my b. So my two key numbers are 3x and 4x. So now let's find the GCF of all of these horizontals. So here, I don't have any numbers, but I can separate x squared into x times x. So x, and I can pull this x out of this. And so I can cancel one x from both of these terms. So my GCF here is just an x. And now on top, let's see what we're left with. And so I've got this x squared. All I'm left with after I cancel out this x is just 1x. And all I'm left with here is just my 3 after I cancel out the x there. And so now once we find the GCF here, it should match up to leave us remaining with this. So let's check that out. So this time I'm not going to, I can't take any variables away from this 12, but I can separate this 4 into 4 times 1, and this 12 into 4 times 3. And so now I can cancel a 4 out from both of those. So my GCF is just a positive 4. And all I'm left with here is just an x. And all I'm left with here is just a 3. So my two factors are right here. They are x plus 3 and x plus 4, which is exactly what we multiplied in the beginning. So these two are the same thing, but just in factored form versus standard form. We're going to do 3 more examples of some different scenarios that we may run into. So let's set up my box method here. My a is 3. My b, I want to include this sign with it. So here it's going to be -2, and my c is going to be -5. So now 3x squared would go in this box, and -5 would go in the last box. And so now we have a times c, which is 3 times -5, which is going to get me -15. And we need it to add or subtract to b, which in this case is -2. So I'm thinking, what numbers multiply to -15? Well, I can say that 3 times 5 would multiply to 15. And if I make this 5 negative, 3 minus 5 gets us that -2, which is exactly what we're looking for. So we're going to say this is positive 3x and a negative 5x as my two key numbers. Now let's find the GCF. Here I can separate this 3 into 3 times 1, and I've got a 3 here that I can separate into 3 times 1. But I can also separate these x's into x squared, so x times x, and then an x up here. And now let's see what we can cancel. I can cancel a 3 from both of these, and I can cancel 1x from both of these. So my GCF is 3x, because that's what we canceled. And now we're left with just an x here. So I'm going to say this is x. And here all we're left with is this 1. So I'm going to say plus 1. Let's do the same thing on the bottom row now. I can separate this into 5 and 1, but I want a negative here, so I'm going to make this -1. And then same thing, I can divide this into 5 and -1. There's no variables, there's no x's for me to cancel out here. But in both of these, I can cancel out a 5 and a 5, and a -1 and a -1. And so my factors are 5 and -1, which is just going to give me -5. And when I do that, I'm left with an x, and here everything cancels, so I'm just left with 1. So my two factors are 3x minus 5 and x plus 1. For my third example, when I look at this, I notice it's a little bit different. I've got 2x cubed minus 4x squared minus an x. So this isn't in my standard form, which should be ax squared to start off with. We talked about in a previous lesson that factoring GCF is always going to be my very first step to factoring. And that's exactly what I need to do here. We need to factor out a GCF before we can do anything else. So I can separate this 2 into 2 times 1. This 4 I can separate into 2 times 2, and this 6 I can separate into 2 times 3. And now I can do the same thing with my x's. X cubed can be separated into x times x times x. X squared can be separated into x times x. And then this would just be 1x. And so now I can cancel anything that I have in all three of my terms. So down here at the bottom, I have a 2 in each of my terms. So 2 is going to be a part of my GCF. And then I can cancel 1x from each of these three terms. So my GCF is 2x. And now in my parentheses, I just have to see what I'm left with. In this first term, I'm left with just a 1, but 2 x's. So I end up with just 1x squared. In the second term, I'm left with a 2, and I still have this negative. So it's going to be negative 2, and then just 1x, so negative 2x. And then here I'm just left with 3, and this negative, and all of my x's canceled, so I'm just left with negative 3 here. And now I can use the box method for this inside part here, inside my parentheses, and then I'm just going to tag on my GCF at the very end. So I'm going to set up my box. X squared will go on my first box, and negative 3 will go on my last. And so now let's think of our two key numbers. A times C, so here we have A as 1, B is negative 2, and C is negative 3. And so A times C is going to get me 1 times negative 3, which is just negative 3. And the only things that will multiply to 3 are 3 and 1. But I want these to add or subtract to a negative 2. So I'm going to make this 3 negative, because 1 minus 3 gets us negative 2, which is what we're looking for. So my two key numbers are negative 3x plus 1x. So now let's see what we can take away from all of these terms here. X squared can be separated into x and x. And then I just have this x here. There's no number that I can pull from this x squared. So my GCF, I can take away an x from both of those. So my GCF is x. And now here, I'm left with just one more x. And here, after I cancel out this x, I'm just left with a negative 3. And now in this second row, I've got 1x, which is just 1, and then an x. And then this 3 we can separate into 1 and negative 3. And so now what do I have in both of these terms? Well, I have a 1 both of these. So I can just say plus 1. And that does leave me with an x and a negative 3 up top. So my two factors are x plus 1 and x minus 3. But remember, we need to bring this 2x down as my GCF. So this would be my factored form of this original trinomial. We've got one more weird example. This time we have x squared minus 81. So when I look at this, it doesn't look like our original standard form either. I'm missing a b. I don't have any x terms. And so I can think, what number is no number? Well, that would just be 0. So I could actually rewrite this into x squared plus 0x's minus 81. And now I can see my a is 1, my b is 0, and my c is negative 81 if I keep that sign with it. So I'll set up my box. X squared will go on my first one, and negative 81 will go on my last. And so now let's think. A times c is 1 times negative 81, which just gets us negative 81. And now we want two numbers to be able to add or subtract to 0. So I'm thinking, the same number minus each other is going to get us that 0. And luckily 81 is a perfect square, we can separate that into 9 times 9. And if we make one of these negative, 9 minus 9 does indeed get us 0. So my two key numbers are positive 9 and negative 9. Now let's find the GCF. Here I've got x squared, which can separate into x times x. And I've got this x here. So I can take away 1x from both of those, which means my GCF is x. And then here I'm left with just 1x. And then I'm just left with this positive 9. And now here, I don't have any variables I can get rid of. But this negative 9 can be separated into negative 9 times 1. And negative 81 can be separated into negative 9 times positive 9. And now let's cancel out. I've got a negative 9 on both of these. So I end up with a negative 9 as my GCF. And all I'm left with here is x and positive 9. So my two factors are x minus 9 times x plus 9. So to summarize, we can use the box method to multiply binomials or to factor trinomials. We put our a in our first term, in our first box, and c in our last one. And then we just need to find two key numbers that multiply to a times c and add to b. Once we get that, we find the GCF horizontally and put our remainders on top. And the top and the side will give us our factors.